All right. So welcome everyone. My name is Warren Brown. I'm the chair of the Optical Infrared Telescope Time Allocation Committee at the Center for Astrophysics. And the TAC, as we call it, the Time Allocation Committee, its role is to oversee the scientific use of our telescopes. So the purpose of what I want to talk about today is to highlight the capabilities of our telescopes and to encourage you to go use them. I've planned this sort of as an executive summary. I'm happy to stay around afterwards to talk about details or have one-on-one sessions with people. I see a number of grad students in the call, which is great, and I'm happy to answer questions as best I can. And just for the record, the contents of this talk are almost entirely publicly available on the TAC web pages on the CFA system. Okay, so let me screen share. Okay. Okay, yeah, and so the TAC web pages, share a little bit. Yeah, the TAC web pages, it has a very long path these days in the new web system, but it's www.cfa.harvard.edu/TAC. That old link will jump you straight to the TAC web pages. Okay, so to begin, so CFA astronomers have access to three great facilities. The MMT, formerly a multiple mirror telescope, was upgraded over 20 years ago now to a single 6.5 meter telescope. It is jointly run by Smithsonian and University of Arizona, and it's located on Mount Hopkins in Arizona. Let's see, can I turn on the Zoom button? Let's see. Laser, here we go. All right, so this is the MMT. Also located on Mount Hopkins in Arizona is the Fred Lawrence Whipple Observatory, which is owned and operated entirely by Smithsonian. It has a dedicated 1.5 meter that's dedicated to spectroscopy and a 1.2 meter telescope dedicated to optical imaging. So Magellan are actually 6.5 meter twins of the MMT located on Las Campanas in Chile. Magellan is run by a consortium of 6 institutions, of which Harvard is a 20% partner. Importantly, Smithsonian and Harvard have agreed to share all these facilities so that any CFA astronomer can apply for any CFA time on any CFA telescope. So telescope time is scheduled on a nightly basis. Nights are classified by moon phase. Generally speaking, if your targets are brighter than the sky background, you can use bright nights when the moon is up. And if your objects are faint, you need dark nights when the moon is down. Bright nights tend to be the domain of the infrared instruments or the Echelle spectrographs that target bright stars, while dark nights tend to be the domain of the deep optical spectrographs and imagers. So all of our facilities are now scheduled on a semester system. Our 50% share of MMT nets us approximately 26 dark plus 13 gray plus 26 bright nights per semester on the telescope. Summer shutdown reduces the number of nights in the second half of the year, the B semester, by about 10 nights. So just be aware of that. Our 100% share of the Whipple telescopes give us approximately 72 dark, 36 gray, and 72 bright nights per semester. And again, the summer shutdown reduces the number of nights available in the B semester, in this case by about a month. And our 20% share of the 2 Magellan telescopes gives us approximately 21 dark plus 11 gray plus 21 bright nights per semester, evenly split between the 2 telescopes. And the way these nights are allocated to us is it's generally, we're given a couple bright and dark nights per month by the observatory, and that's what we have to work with. So that's the time available. What you do with the telescopes depends on the instrument, and CFA astronomers have access to some great instruments. I've put some pictures up here of some of our workhorse spectrographs. On the 1/2 meter, actually it's the trace spectrograph that actually is the workhorse these days. It's a single object fiber shell spectrograph. And on the MT, we see a picture here of the focal plane of the 300 fiber robot positioner, which can be plugged into hectospec or hectoshell, depending on what spectral resolution you want. And this gives you a 1-degree field of view on a 6-centimeter telescope. So in the interest of time, I'm not going to talk about every instrument, and instead try to focus on the big picture. So this table, which is probably impossible to read, is on the TAC webpage, and it shows everything we have, and it has links to each instrument webpage. The table's organized by telescope, and the instruments highlighted in yellow are the optical instruments. The instruments in sort of this light purple color are the infrared instruments. The Whipple telescopes are easy. The 1.2 meters dedicated to optical imaging, the 1.5 meters dedicated to optical spectroscopy. The MMT and Magellan are much more fully instrumented and give you a lot more options. That said, there's sort of strengths and weaknesses of each of the facilities. To give you a sense of things, I made a plot here showing the instrument use of the MMT over the last 3 years. The strengths of the MMT are really spectroscopy. Into the near ultraviolet with our single and multi-slit spectrographs, the blue channel and binospec spectrographs, or the 1-degree field of view capability with the fiber, hectospec, and hectoshell spectrographs. The infrared multi-slit spectrograph and imager mirrors here accounts for about the remaining 20% of the time over the last 3 years. To make a similar plot for Magellan is harder because we have such a smaller fraction of the time at Magellan. But I think it is fair to say that Magellan is probably the better imaging site. The nights tend to be more photometric and have better seeing on average. And Magellan also has shell spectrographs with optical and infrared that the MMT does not. All right, so the next column on this table tells you what instruments are currently available for proposals. Notably, the adaptive optics systems, both at MMT and Magellan, are not currently available. And there's also some PI instruments that actually regularly are on the telescope, but they're not facility instruments. And these you actually need permission of the PI to propose and use. M2FS is probably one of the most popular at Magellan. The final column here indicates how the instruments are used. And I've tried to put a bunch of information here in one place. So Q refers to how Q observing, meaning that approved PIs submit their target catalogs in advance, and then the observations are obtained by our surface observers throughout the course of an instrument run at the telescope. So there's many advantages to Q observing, one of which is that you're guaranteed to get some data. Weather losses at Mount Hopkins tend to be about 30%, but correlate depending on the time of year. Q observing also enables certain types of observing, like targets of opportunity, or exact windows of time needed for transit, or sort of long-term monitoring programs, things that are very difficult to schedule on just a classical night, like we have to work with at Magellan. And so you can see that essentially all the instruments at Whipple and at MT are running Q mode, and the instruments at Magellan are not. So going to the telescope is still the best way to learn how to observe and use an instrument, but there's other ways to observe now. And so this remote column indicates whether you can use this instrument remotely via internet. So you can see the MMT blue channel for over a decade, you've been able to remote observe with this instrument. And thanks to COVID, Las Campanas has allowed us to start remote observing at Magellan as well. And essentially all facility instruments can be operated remotely via internet. I've done this myself, and actually it works remarkably well. In part because all the useful information like the web Skype cams and things like that are online now. So you have the information needed to observe effectively. The final column on this plot marks whether there's surface observing. So for the Q instruments, this is required. But the new development, or relatively new development, is the CFA has acquired the services of a service observer at Magellan, Yuri Beletsky. He's a very good observer, and he's available to observe almost all of our nights. There are times when there's conflicts and PIs still have to observe, but by and large, Yuri is a great resource for people wanting to do Magellan observing. So another important issue is data reduction and software support. So most instruments have data reduction software, but the quality varies. And frankly, the one-size-fits-all types of pipelines typically don't work as well as things that are carefully crafted for their instrument. So I would say an exception to the rule are the instruments built and run by SAO. So the Telescope Data Center, or the TDC, is a small number of staff whose job it is to archive, process, and distribute data. They've written these data reduction pipelines, they manage our proposals, the public archive, and otherwise facilitate the scientific impact of our use of these telescopes. And they do this, for example, by taking a nightly data set from hectospec, which can look very complicated, and processing that and distributing the reduced 1D spectra to astronomers, which makes it ready for you to analyze and publish. So really the idea is to remove a barrier to doing the science by providing the data reduction. The TDC currently archives raw data from every instrument at Whipple, every SAO instrument at MMT, and every CFA observer's data from Magellan. That's what we have access to. In addition, we run data reduction pipelines for all of our spectrographs, you can see listed here. And typically the data is processed and distributed within about a working day to the PI. At MMT, we've actually gone to the point of almost automating it. It's not quite, but the data is available on the MMT server, which is it's a one-stop shopping now, which is nice. I would say one exception is MegCam. That data set tends to be very time intensive to process, so that takes a while. The current data archive is actually up to about 100 terabytes and includes hundreds of thousands of spectra that we've processed and archived and distributed from our spectrographs. I'll take this moment to advertise that we have a portal for publicly available spectra, the OIR Science Archive. This archive we've hosted on the cloud so that it's actually accessible to the outside world. And it runs on a VO-compatible server, so which means you can perform table access protocol queries on it using a tool like Topcat. This public archive currently contains a large fraction of our hectospec, fast, and old shell spectra, and we're kind of trying to add new data sets as we move forward. The key being that we're providing the processed data, not the raw data. Okay, so proposals for all these instruments are submitted with our online system, TDC Apply. Again, you don't need to write down this web link. This is available, linked straight off the TAC pages. But this is what it looks like, the splash page on the web page. Let me mention that because of the way we do our bookkeeping, it's important that you submit a separate proposal for every instrument that you want to use, even if it's for the same program. So in that instance, your proposal could be essentially identical, but we need to account for every instrument being scheduled. So for example, Binospec and MMT or IMAX and Magellan requires different scheduling of different observatories. So our bookkeeping requires a separate proposal for each instrument being used. Proposal must contain a few things, the most important of which is the scientific justification. There's a 2-page limit on this. So the TAC wants you to be direct and get right to the point. Standard points that you should address include statements about what question are you answering, what new is being learned, why is this important, the motivation. TAC also wants to see some statements about the experimental design. Is the proposed observation feasible? Are the exposure times, do they make sense? Are the proposed measurements actually directly leading to the result you're looking for? And is that publishable? That's a word the TAC loves to hear. And I think it's fair to say that the highest ranked proposals are the ones that clearly state how, a well-defined set of observations will answer a question, or test a theory, or make progress to a clear endpoint. The TAC is less impressed by proposals to observe, yet another object. It's not clear how it makes any progress in understanding. So starting a few years ago, the TAC also began requiring an addendum part to the proposal. And this was meant to address some common concerns. First of all, is this proposal for CFA scientists doing science at the CFA? For long-term programs, are you getting it done? And how many more nights do you need to complete the program? And finally, target distribution. The TAC doesn't really need exact coordinates for objects, but we do need to know roughly where they are on the sky. The example being that very often we'll get proposals for something that's setting at the very beginning of the semester or rising at the very end. And there's very few hours on sky that we can schedule for such objects. And if more than one proposal wants that, that's just not possible for us to allocate that much time to those types of targets. So this is what that's trying to address. Okay, so we have a copy here, sorry. Live transcript. Okay. All right, so this is what the telescope proposal system looks like if you click create a proposal. So you log in, you can click create a proposal to start one. The first step is to fill out a cover page, which is kind of what the screenshot shows you here. And what the TAC really wants to know, as I pointed out before, is the number of nights you need for this program to get to the final published results. And then these are sort of the fields that we talked about a little bit. When you're done, you click cover page, and the cover page is generated with this information. You can then upload your justification as a PDF file. We provide a LaTeX template linked on the TAC pages you can use, or you can generate a PDF in other ways. But once you click upload PDF, you can then create what's this button called create TAC PDF. And that creates the final package that the TAC members will see and read. And finally, don't forget to press submit when you're done. Okay, so in terms of process, each member of the TAC will read and grade every proposal. The grades from each member are normalized so that they have the same mean and dispersion, and then they're averaged together to form a rank order list of proposals per telescope. Proposals then allocated time on the basis of their ranking and the availability of time. And in detail, the TAC discusses proposals, so they try to take into account other information as well. But this can be complicated for telescopes like Magellan, which requires that we schedule with many other partners. It's not always possible to get the nights that we want to allocate. So to give you a sense of what is allocated, these plots show you the number of programs that are allocated certain number of nights per semester on Magellan and per trimester back then at the MMT over this 4-year period, or 3-year period. So you can see, so on the top is the histogram and the bottom is the cumulative distribution. So you can see there's a tail of a few percent large programs. These are the HS Red, Stellar, Halo Survey, and the MMT, and some exoplanets programs at Magellan. But the median proposal is allocated 2.5 nights at Magellan and 2 nights per trimester, which is equivalent to 3 nights per semester at MMT. So roughly speaking, 2 to 3 night proposals are the norm, and allocations over 4 or 5 nights are really the exception. All right, so this plot shows you the subscription rate for the Magellan Bada, Clay, and MMT telescopes over the past decade. There's a lot of scatter, but the average sort of oversubscription of MMT is about 1.5, which means that, roughly speaking, the top 2/3 of proposals get the time they ask for, and the bottom 1/3 of proposals do not. Now, the subscription rate for Magellan has in recent years been lower, but ironically, that flipped last semester. The Magellan Bottom was actually our most subscribed telescope by about a factor, oversubscribed by a factor of 2. So I think that perhaps the availability of service and remote observing has finally made Magellan a little more accessible for people. A positive way to see this plot is that there's plenty of time on our telescopes for high-ranked proposals. And some of the highest-ranked proposals come from young scientists and postdocs. And so I encourage astronomers, young and old, to apply. There are opportunities to do great science with our telescopes. The next proposal deadline is about 4 weeks away. They're due at noon Eastern time, in this case on April 12th, for the proposals for the second half of this year, for the B semester, on all of our facilities. All right, so at this point, I will stop and take questions. And I guess use raise hand or, oh, thank you. Questions, anyone? Tony, yeah, go ahead.
Can you talk about the COVID restrictions and what's likely to happen in the future?
So COVID restrictions mostly prevent travel at this point. So Whipple and MMT, well, Whipple now allows visiting astronomers to use the dorms and to arrive. MMT is still pretty restrictive about people on the summit. So they've actually asked the Blue Channel observers to continue remote observing. But you can visit Whipple. Lost components, it's always changing. So it depends on the Chilean situation. Currently, LCO is not welcoming outside visitors, but that may change. Yeah, it's hard to plan because it's always changing. It's part of the answer.
Is anyone looking at protoplanetary disk molecules in the micron range?
No, we don't have too many active star formation programs at the moment. That certainly sounds more like a submillimeter type of program than an optical infrared program. Yeah, so speaking of COVID, I guess it's worth assuring people that the observatories are more or less back in normal operation. There's been hiccups. You know, a month ago, LCO went down to 1 telescope operation for the Magellans and went back to 2 telescope operation. Some staff got COVID and they had some restrictions. And at MMT, the issues have more or less been instrument related. If an instrument has to get worked on, it takes much longer for the instrument to get repaired these days. So they rearrange the schedule, which impacts everyone. But roughly speaking, the observatories are more or less normal operation, just harder to get at them these days. Yeah, Dave.
So I run the queue for the Tillinghast reflector, a shell spectrograph, which is getting a lot of the time now. And that's supporting about a dozen different PIs that are doing stellar astrophysics and exoplanet work. And if you are thinking about using that instrument, you ought to talk to me ahead of time and I can give you some guidance on what we can do and how you propose.
Thank you, Dave. Yeah, and I'm happy to point people to, we have sort of regular long-term users of a lot of different instruments on our telescopes. So if you're new to proposing, I'm happy to point you to the local expert. You know, if I don't know the answer, there's someone around the observatory who probably does. And Dave is the master of the trace spectrograph. Yes, Daniel.
It just seems at this point that Dave brought up and you brought as a general point that, this is not like some national time allocation process where, you're applying and the proposers all have to be, the committees have to be very arm's length from the reviewers and from the proposers and so forth. Like, it would be much better if people approached Warren and other experts to get advice on their plans before they propose, so they're actually writing more successful proposals and better proposals. This is just not a situation where you have to view it as like some protocol that you have to be kept at arm's length.
Yeah, and I think the general attitude, the TAC loves to give everyone time as best they can. And even proposals get ranked poorly, we'll often give sometimes a pilot program to see whether they can show that it works and come back next time. So I think the TAC really does try their best to give time. And the hard thing is when we're really oversubscribed, then it's just not available for everyone. But we do try to make sure people get to use our facilities. Dave?
So I've been known on occasion to take test exposures before you submitted a proposal so you can see whether it's going to work or not.
Yeah, that's the real value of having our own facilities. We have the flexibility to do things like that. Tony.
Yeah, so this is getting kind of down into the details, but I've been using 4-star, which is really a wonderful instrument, but the data reduction software on the site is essentially hopeless. And I've only been able to reduce the data because my colleagues at University of Chicago wrote their own pipeline to do this. And so I think there is in fact an issue for people here who might want to use that instrument, which is a really interesting instrument. And in some sense, it's a replacement for Warren Spitzer, and it has comparable capabilities, but the data reduction software is just appalling.
Yeah, that's been a complaint at Magellan since forever. That's sort of their model. They support the operations at the telescope very well, but the data reduction and archiving support is zero at Magellan, right? They have no archive. The only way our data gets transferred is we have our service observer put it in Google Drive. The telescope data is in our Google Drive.
Yeah, well, I think with sort of a person month of work that a pipeline could be put together in the Anaconda 3 Python environment. If someone were, if there were some way that we could get someone to do that, or, I mean, I suppose I could do it, but I just don't have a free month.
Yeah, it's tricky. Every time you think there's an easy project like us doing the public archive, we're like, oh, we have uniform sets of process spectra. It turns out in detail, there's nightly observations are a mess. There's no exact protocol data is taken. There's all sorts of complications, and nothing ever takes a month. We've learned the hard way. And just maintaining the current pipelines takes most of our bandwidth. But if there's a big user base for an instrument, we can certainly look into expanding support. We really focus our attention on our own facilities and instruments. But yeah, I mean, this is something, frankly, that the Magellan Science Advisory Committee could really push. Right? I don't see why someone at LCO can't do that. That's an observatory issue at some level. Catherine.
Yeah, going back to kind of the allocation process, is it seen as an all or nothing? Like if you ask for 4 nights, you either get it or you don't, or is that then if you're highly ranked, but not quite highly ranked, it might get cut down to, 1 or 2, depending on how the timing is allocated?
It depends. So when we're sort of evenly subscribed, everyone gets the time they ask for. When we're heavily oversubscribed, then the top ranked proposals always get the time they ask for. And somewhere around the dividing line, the TAC usually starts making calls like, well, maybe they can make progress with half the time, then we give a night to this other program too, and so everyone gets some progress. So it depends on the semester.
Okay.
But we generally, as a general rule, particularly for the postdoc programs where we know they have a short time scale, and if they've had problems, we'll round up proposals. We're like, okay, this program needs another night or two. We want to see it get done. So we go both directions on that. I think the TAC has a memory of what's happened over the last few years and tries to be as fair as they can about it.
Okay, thank you.
Martin.
Yeah, hi. I just thought I'd comment. I'm the SAO representative on the MAGSAC, the Science Advisory Committee. We've looked into building an archive, and all the problems you mentioned are actually worse than you went into. But there is the idea that all new instruments will have to have an archive because NSF won't give money for new instrumentation unless we do that. So going forward, it looks good, but going back is going to be very challenging. I'd also like to announce that since I am this representative, I would like to actually represent people and come to me, send me emails with any questions you have and issues about Magellan and SAO and CFA, really.
So this is Martin Elvis, if you're looking for the
Sorry,
email address.
yes.
So are there questions from our younger attendees? I see a number of postdocs students on the call. I'm happy to answer questions or chat me afterwards if you want to talk more.
Let me mention one other thing. If you're interested in CCD imaging with KeplerCam on 1.2 meter telescope, then talk to Alison Barilla, because she'll help anybody who gets time or is thinking about proposing.
Yes, happy to do that. And I'll just also say is, even though we don't have an official pipeline, there's definitely multiple groups, myself and service observers that have a pipeline that's not officially run by the TDC. So happy to talk about reductions as well.
And we have an archive, but you do have to get access to the archive if you want to use existing data.
That's right.
Yeah, all of our systems are legacy of the past when they were originally built. So it's easier to build these things fresh from the start, right? There's a reason why the BinaSpec system looks modern, because it was built, recently. Okay, well, I think does it. If there's no more questions, like I said, feel free to drop me an email for those who want to chat more. But otherwise, thanks for showing up. I encourage everyone to propose. We have great facilities here.